Okay, practice G. Let's start with the first one. It says 33 because these are problems from the end of your chapter. So these are going to have different applications. So number 33, remember, when we read a problem, we want to chunk it. It also helps to draw a diagram because when you draw a diagram, it helps you to visualize it, and that's going to be essential for this problem. So it says that the average speed of an orbiting shuttle is, so I'm going to write my given. The speed is 27,800 kilometers per hour. Determine the time, so I want to find the time, required for it to circle Earth. Assume the shuttle is orbiting 320 kilometers above the Earth. So already I'm trying to get confused because I'm not sure what they're talking about. So what I'm going to do is I'm going to draw a picture of Earth. So here's the Earth. And now they're telling me it's orbiting 320 kilometers above the Earth. So that's this distance here, which I'm going to call O for orbit. So there's the shuttle. So the orbit is 320 kilometers. And the Earth's radius, so this is now the radius of the Earth, is equal to 6,380 kilometers. Now, obviously, I didn't draw this to scale. Okay. So now here is the shuttle, which I don't use anymore, going around the Earth. So we want to find the time. So I'm looking at this. I see my given. I see my find, but I'm kind of not sure what to do because when you're not sure what to do, you go to the end. So that's why we write our given and our find. So I know that I want to find the time. Now they also gave me the average velocity, and one of the first equations that we learned that speed is equal to distance over time. And you learned that same equation in middle school. And that's all this is. Now what made this problem challenging is the diagram, the circumstances. Okay, so now if we think about it, we have the average speed, we have the distance, so we want to find the time. So we're going to rearrange the equation and say time is equal to distance over speed. Okay, so now we have to think about it. This orbiting spacecraft, as it's going around the Earth, is the distance in a straight line? No. The distance is going around the Earth. So this is what we have to find the distance of right here, and this distance is going to be the circumference of a circle. So the circumference of a circle is 2 pi r. And now what makes this problem tricky is, here's the part where they try to trick you. This is the circumference that we want here, and the 2 pi r, the actual radius, remember, is from the center, so we have to add these two together. So we add the distance from the center to the surface, and then from the surface to the shuttle. So this 2 pi r is going to be 2 pi times, and we're going to add those two together, 6380 plus 320, okay? So when we add that, it's going to be 2 pi times 6,700. So then when we put that in our calculator, 6700 times 2 equals times 3.14 equals, we get a big number. So it comes out to be 42,076 kilometers. And now I go back to my original equation here, and I put this down, and I say that time is equal to distance over speed. So it's going to be 4,276 kilometers divided by 27,800, which was given, kilometers per hour. So now my calculator divided by 27,800 comes out to be 1.5. Now the unit is supposed to be hours, but I need to remember, in physics we have a foolproof way to check our work. So in the numerator I have a kilometer divided by a kilometer over an hour, which is a kilometer times an hour over a kilometer. These cancel and I end up with hours, which is my correct unit for time. So when you probably first read this problem, you're like, oh, I have no idea what to do. I'm not sure what to do. So if you notice, if you draw a picture, it makes it easier to conceptualize. What was the physics involved in this problem? This was the physics right here. Speed is distance over time. So you notice that the physics really wasn't that difficult. We had to know the circumference of a circle. We had to rearrange the equation. We had to check our units. But the physics was just speed is distance over time. All right, let's do another one. Let's do number 37. So number 37 says a rocket moves upward starting from rest, so the initial velocity is 0. With an acceleration, so the acceleration is positive 29.4 meters per second squared, and the time is 3.98 seconds. It runs out of fuel, but does not stop. How long does it rise above the ground? So this is definitely something where I want to draw a picture, because if I don't draw my picture, I cannot visualize this. So first I'm going to draw the ground, and I have the rocket here, VI. It's going to start off, and it's going to go up during this 3.98 seconds. So when it goes up, it's going to reach a certain speed. But then, after the fuel runs out, it's still going to go up a little bit more. So what happens is I have this first distance I'm going to call y1, and then I have the second distance I'm going to call y2. And the problem asks, well, how high does it go? So I'm going to call this y total. And this is why I really need to draw a picture to help me visualize this. And again, these are the most challenging type problems. Our FRQs are not going to be this complicated on the test, but when you go on to take college level physics, every problem is going to be like this. And that's how we still have to understand how to do these. All right, where do we begin? What I would do is I would definitely start you do one thing at a time. So we're going to start over here with this first motion here. We're just going to ignore right now after it runs out of fuel, and we're just going to do the first part is going to be with the fuel. So what do we know? Well, we're going to write down what are we given with fuel. All of the stuff is our given with fuel. We have VI. Or no, we have the initial velocity. Or what do we have? It starts from rest, so VI is 0. We have A. And we also have T. So if we have VI, we have A and T, and we want to find this Y1. So now I'm going to say to myself, well, which equation has those four variables? So my four variables are VS, VI, no, whoops, we don't have the F. We have VI, we have T, we have A, and we want to find Y. So I'm going to say which equation has those four variables. So that's the equation that Y is equal to VIT plus 1/2 AT squared. Now, because VI is 0, the whole term goes to 0, because remember, anything times 0 is 0, so I'll just get rid of that term. Remember, this is what I'm calling Y1. So if I look at my picture, from here to here, when I have fuel, that's what I'm counting, how high it is there, right? So Y1 is equal to 1/2 AT squared. So it's equal to 1/2 29.4 meters per second squared times 3.98 seconds squared. So when I do that on my calculator, 3.98 squared times 29.4 equals divided by 2 equals, I get 232.85, so I'm going to say that first distance is 233 meters. So, from here to here, I figured out how high it goes with the fuel. Okay? But the question says, at this point here, it now ran out of fuel, but it's going to keep going. So how much further does it go? And then the question said, how high above the ground is it? So I have to figure out this distance here, which I'm going to call Y2. Now, for part 2, if I want to figure out Y2, remember this is without fuel, and I also want to figure out Y2. The problem is, if I want to figure out Y2, what do I know? Seems like I don't really know that much. Well, it's going to start off with a certain velocity here, and then as it goes up, because gravity's pulling it down, when it reaches the top here, the final velocity is going to be 0. I know that G is going to be negative 9.8 meters per second squared because it doesn't have any fuel, so the only acceleration acting on it is the acceleration due to gravity. So it's kind of like one of the problems that we did last week where I throw something up in the air and gravity's pulling down. Now the key to this problem is whatever the velocity was here, whatever the final velocity was for the first part with fuel, that's going to be the initial velocity for the second part. So that's the key, and that's why you have to look at the picture. So when it goes up, whatever the final velocity is for this part, that's going to be the initial velocity for the second part. But the problem is I don't know what that is. So I have to figure that out. So for this part, the VF, I can use VF is VI plus AT. So VF is equal to 0 plus 29.4 meters per second squared times 3.98 seconds. So VF comes out to be 3.98 times 29.4. So it comes out to be 117 meters per second. So when it had fuel, it started off at 0. It was going up, and at this point, the velocity was 117 meters per second, and then it ran out of fuel. So now, as it's going up, it doesn't have any more fuel. It starts off here now, VI is 117, gravity's pulling it down, and then when it gets to its maximum height, the velocity is 0. So I see I have three things here. I have VF, I have G, I have VI, and the last thing I want to find is Y, and this is going to be Y2. So which equation has these four variables? Well, it's the equation VF squared is equal to VI squared plus 2GY. Since I want to solve for Y, I'm going to rearrange the equation to solve for the unknown in terms of the known. So you see how this has a plus here? So I have to subtract this from both sides. Now remember, when you want to isolate something, you want it to be in the numerator on one side of the equal sign. So since this is already like by itself, I'm going to leave that alone. I'm going to subtract this. So I'm going to say VF squared minus VI squared is equal to 2GY. But remember, I want to get the Y by itself, so I'm going to divide both sides by 2G. It's important to know order of operations in math. So I'm going to have VF squared minus VI squared over 2G is equal to Y. So now I'll substitute my values in. VF is 0, minus VI, which is 117 squared, over 2 times negative 9.8. Now what you'll see is that this negative and this negative are going to cancel. So now I'll have 117 squared divided by 2 times 9.8, which is 19.6. So it comes out to be 698 meters. But the problem said, what is the total height? The total. So the total is equal to y1 plus y2, so it's equal to 233 plus 698, and it comes out to be 931. Now, if I didn't draw this picture, I don't think I'd be able to do this problem. Where a lot of us are very visual, and that's why when you draw a picture, it helps to conceptualize the problem. So even though this problem has steps that we've done before, putting it all together, that's like a whole nother level. Now, in some college courses, this is every single problem they're going to have on a test. So we have to know what to do, that it's really not that difficult, know the physics, but to understand what to do in the problem, because if you did this by yourself, maybe you'd be like, I don't know where to start. And that's why what you do is you look at the picture. And when you draw the picture helps you to figure out what to do next. That's why a picture is so important in physics. No matter what we do, we need to have a picture. All right, we're on a roll. Let's do another one. So let's do 38. Okay, so 38 says 2 cars travel westward along a straight highway. So we're doing number 38. One at a constant velocity. So I'm gonna need to write my given now. So I have 2 cars, I'll call that one V1, and it's 85 kilometers per hour. And the other at a constant velocity of 115. So I'm going to call that one V2. Assuming that both cars start from rest, so that means their initial velocity is 0. Oh no, assuming both cars start at the same point, how much sooner does the faster car arrive at the destination 16 kilometers away? So we know x is equal to 16 kilometers. So what do we want to find? So we want to find A, T, and then it says how far must the cars travel for the faster car to arrive 15 minutes before the other one. All right, so let's set up this one, because this is kind of like a classic. All right, so where do we start? Well, the question says, assuming both cars start at the same point, how much sooner does the faster car arrive at the destination? So we have velocity, we have displacement, and we want to find time. So we're going to say, well, which equation has those variables? Well, that's the equation V is equal to x over t. So what we have to do is we want to find the time for both the cars. So I'm going to rearrange the equation. Now, this is where people make a mistake. If you need to take intermediate algebra steps and multiply both sides by t, and then divide both sides by v, t is equal to x over v. Now, sometimes what you guys do is you do it in your head, and when you do it in your head, you might end up saying, like, t is equal to x times v, and that's not correct. So you need to check your algebra. It's not the physics, it's the algebra. So let's start with T1. So T1 is going to be x times V1. So it's 16 kilometers divided by 85 kilometers per hour. So 16 divided by 85 comes out to be 0.188. So I'm going to say 0.19 hours. Now, physics is so great that I always have a foolproof way to check my work. And if I don't do that, then I'm the fool, because then I can make a mistake. So let's look, and a lot of times, again, once you're used to this, some of you can just say, oh, this cancels with that, and I end up with 1 over 1 over an hour. So 1 over 1 over an hour, that's 1 divided by 1 over an hour, which is 1 times an hour over 1, which comes out to be an hour. So that's the correct unit. So in case I made an algebra mistake there, I would check it when I carry my units through. But you'll get to the point where you don't have to write it like that. You can just look and cancel. Okay? So it takes just another extra couple of seconds to check your work. Okay, so now let's look at the other time. So for the other one, T2 is equal to x over V2, which is equal to 16 kilometers divided by 115 kilometers per hour. And now I'll do that on my calculator. 16 divided by 115 equals, and it comes out to be 0.139, so this one's going to be 0.14. So it wants to know, I think the question asks for the difference in time. It says, how much sooner does the faster car arrive? So when it says sooner, it wants the difference. Okay, so now we have to find the difference in time, delta t. So delta t is going to be 0.19 minus 0.14, which comes up to 0.5 hours. So now part B says, how far must the cars travel for the faster car to arrive 15 minutes slower than the other one? Well, first of all, if you notice, it says the word minutes. So this is where they're trying to trick us, because everything we've done thus far has been in hours. And all this stuff is in hours. So what I would do is I would first take that 15 minutes, so delta t is 15 minutes, and I would convert the minutes to hours, so this way it's 1 hour, and I know 1 hour is 60 minutes. If this is in the numerator, minutes, I put it in the denominator, and I want to go from minutes to hours, so now these cancel. And then 15 divided by 60, I could do that in my head, it's 1/4, so it's going to be 0.25, and that's the difference. So now I'm going to use this information. That's the difference. Okay. Now this question says, the key here are, for there to be a 0.25 hour difference, remember the x's, how far they went, are the same. So that's the key here. So first we're going to say v is equal to x over t. Oh, sorry. So x is equal to v times t. So let's do it for x1. So x1 is going to be 85 kilometers per hour. And now this is going to be t plus 0.25. And then x2 is going to be 115 times t. Because remember, it's the difference. So this part, we want to know when the x's are equal. Okay, so we want to set the x's equal. So again, this problem's a little challenging. So if we set the x's equal, so I have 85 times this, 85 times, remember this is 1x, so x1 is equal to x2. So 85 times t plus 0.25 is equal to 115 times t. And now we have to figure out t. Well, here's the hard part. If I multiply this out, 85 t plus whatever, 85 times 0.25. So 85 times 0.25 comes out to be 21.25. So 80 plus 21.25 is equal to 115t. So now I want to simplify this. Okay? So we're going to try simplifying this. So I keep putting, that's 85t. So I'll subtract 85t from both sides. So I'll have 21.25 is equal to 30t. So t is equal to 21.25 over 30. So then on my calculator, 21.25 divided by 30 comes out to be 0.71. So now, what is this distance? Well, I can either use this equation or that equation. This one's easier. So I'm going to say x is equal to vt. So I'll use this one. So 115 kilometers per hour times 0.71 seconds. And this comes out to be, finally, 115 times 0.71, 81.65. So I'll say it's 82 meters. So this had a bunch of steps because we have to find that point where the x's were equal. Okay, so there's no shortcuts. You can't do it in trial and error. You have to calculate that point. Now, when we go back and look at the graphing worksheet before our test, we'll see how graphically it's easier when we're looking at the graph, but we have to do the same thing. We have to set one equation equal to the other.